Hello everyone, I'm Sebastian Y, and this is Foundations of Economics. In this video, we are going to talk about taxes. Later on in the course, we'll talk about some situations where the free market fails to supply certain goods and services that might still be desirable to people. Some of these things include transportation infrastructure, education, and the military. It then falls to the government to supply these things to the country. Taxes are the main way the government can fund those things. There are two main ways to implement taxes. The first is the simpler of the two, which we call the excise tax. An excise tax is a fixed dollar amount charged for every unit sold. An example of this is the South Dakota tax on cigarettes, which is $1.53 per pack of cigarettes. It does not matter what the price of the pack of cigarettes is, the tax is $1.53 no matter what. The other way to implement a tax is an ad valorem tax. Ad valorem taxes are a fixed percentage of the price. What this means is that goods with a higher price are taxed more, and goods with a lower price are taxed less. One example of this would be the South Dakota sales tax, which is 4.5%. Throughout this video and the rest of the course, we are going to be focusing on excise taxes because they are easier to show mathematically. That being said, the general idea of everything we do here can also be applied to ad valorem taxes. Just like we did with the basics of supply and demand, we are going to approach this from three different angles, using the supply and demand schedules, the functions, and the graph. We are going to return to our example, demand and supply functions that we've been working with several times up to this point. We can use either functions, qd equals 50 minus 5p and qs equals negative 10 plus 5p, to represent these, or we can use the schedules, which I have shown on the left. Back when we talked about supply and demand, we showed that these two are completely equivalent to each other. Suppose the government wants to implement an excise tax of 2 per unit sold. There are two different ways to implement this. We can either charge that tax directly to the sellers, or we can charge it directly to the buyers. We are going to start with the sellers. This means that every time a unit is sold, the sellers have to send that tax money to the government. Let's think about what this means. Previously, at a price of 10, our sellers supplied 40 units. We can see that in the chart. But now, since they're going to have to send 2 to the government for every sale they make, they're now going to require a price of 12 received from the buyers to make up for that, since that extra 2 is going to the government. Similarly, they now need to be paid 11 instead of 9 to supply 35, and we can go from there. You can see that each of these is 2 higher than it used to be. We can use this new tax-adjusted price to figure out what is going to happen in the market. Remember that previously, the price of 6 and quantity of 20 was the equilibrium. That's not going to work anymore because at a price of 6, our suppliers will only supply 10 units. So we need to find the new place where these match up. We can see that this happens at a price of 7. We have 15 units demanded, and then a tax-adjusted price on the seller side, 15 units are supplied. What this means is the buyers are going to pay a price of 7, the sellers are going to send 2 of that to the government and ultimately receive only 5. To describe the outcome with the tax, we need to say all three things. The buyers pay 7, sellers receive 5, and the quantity is 15. We can show this same result algebraically. Since the tax is charged to the sellers, we need to adjust the supply curve to account for the tax. Since the tax of 2 is going to the government, we need to replace our p with p minus 2. Remember to put the 2 inside the parentheses. We can now use the distributive property to clean this up. We get minus 10 plus 5p minus 10. Remember to distribute the signs appropriately. We'll combine the negative 10s to get negative 20 plus 5p. We are now ready to solve for the quantity in the market by setting our quantity supplied equal to our quantity demanded. So we have negative 20 plus 5p equals 50 minus 5p. Do a little bit of algebra here by adding the 5p to both sides, adding 20 to both sides. Divide both sides by 10 to get p equals 7. Now remember that this is the price the buyers receive. We need to plug this back in right here to figure out the price that the sellers receive. So the sellers are going to receive 5. To figure out the quantity in the market, we can plug the 7 into the demand function, or we can plug the 5 into the original supply function. Either way, we'll get the same answer. I'll use the demand function. 50 minus 5 times 7 is 15, which is exactly what we got from the chart. We can also do this using the graph. Remember again that our sellers have to send that tax of 2 to the government, so they now require a price 2 higher than before to supply the same quantity. So we can take each point on our supply curve and move it up by 2 to get our tax-adjusted supply curve. I'm going to make this a dashed line just to denote that this is not really a supply curve, it's just the tax-adjusted one. Then we can see that we have a price of 7 and a quantity of 15, just like we got before. But then remember that the buyers are the ones who are paying 7, and the sellers are receiving 5, with the difference of 2 being the size of the tax. The other way to implement a tax would be to charge the tax to the buyer. Instead of the seller sending the tax to the government, it's the buyer who does it. Since the buyers have to send that tax of 2 to the government every single time, they now require a price 2 lower than before in order to demand the same amount. If we go over to the chart here, 0 minus 2 and 1 minus 2 go into the negatives, and so we're just going to ignore these two lines of the graph. But 2 minus 2 is 0, 3 minus 2 is 1, and we can just fill that in all the way down. We can now figure out what's going to happen. We can see now that we have 5 and 15 over here on the tax-adjusted demand side, and 5 and 15 over here on the supply side, and so that's going to be our outcome. Remember, though, that once the buyers pay 5 to the suppliers, they have to then send the additional 2 to the government. So what we get is the buyers pay 7, sellers receive 5, and the quantity is 15. We can do this algebraically. This time we have to adjust our demand curve. To adjust the demand curve, we need to replace the p with p plus 2, because they're not only just paying p to the sellers, they're paying an additional tax of 2 to the government. We can use the distributive property to clean this up. You have to be careful here about distributing the minus sign, so we get minus 5p, but we also get minus 10. Negative times a positive is a negative. This is going to come out to 40 minus 5p. We now set our two functions equal to each other and solve. I'm going to add 5p to both sides. It gives me 10p over here. Add 10 to both sides. That'll give me 50 over here. Divide both sides by 10 will give me p equals 5. Now this is the price the sellers receive. To know the price the buyers have to pay, we need to add on the 2 for the tax. So this is our seller price, and 7 is our buyer price. To figure out the quantity, we can plug 7 in here, or we can plug 5 in here. Either way will give us the same answer. Let's do the second one this time. So we get negative 10 plus 5 times 5. That's 25 minus 10, which is 15. All that matches up with what we found over here on the chart. Let's go ahead and do this graphically. we're going to set up a new tax-adjusted demand curve. At each point along the demand curve, our buyers now need the price to be 2 lower than before to compensate for the tax. So we can take each of these points and drop it down by 2 to get our tax-adjusted demand. You'll notice that I'm just graphing these points here using the tax-adjusted price. Again, I'm going to use a dotted line just to emphasize that this is not the real demand, this is just the tax-adjusted demand. We can see that our tax-adjusted demand curve crosses the supply right here at 5. That's going to be our seller received price, and then we go up by 2 up to 7 to get our buyer's pay price. Again, the difference is the amount of the tax, which is 2 in this case. Quantity lines up right here at 15. We've now approached this problem a total of 6 ways. We've tried it with the sellers paying the tax, we've done it with the buyers paying the tax, and for each of those we've done it with the schedule, the algebra, and with the graph, and we've got the same answer across all of them. The big takeaway here is that it does not matter which side is charged the tax, the buyers or the sellers, we always end up with an equivalent result. What always ends up happening is the buyers pay more than they used to, 7 is bigger than 6, the sellers receive less than they used to, 5 is less than 6, and the total quantity in the market is lower than before, 15 versus 20 in our example. Since it doesn't matter which side is charged the tax, we actually don't even have to specify, and we can use another technique called the tax wedge to figure out what's going on. What we need to do is find the quantity that is demanded at a price 2 higher than it is supplied, 2 being the size of the tax in our example. We can do that using the original demand and supply schedules without having to worry about any of this tax adjusting business. What we can see here is that at a price of 5, 15 is supplied, and a price 2 higher, 7, 15 is also demanded. Be very careful here because it's tempting to say that the answer is 25, but that is not possible. The tax always reduces the quantity in the market, not increases it. So it's got to be lower than 20, which is the original equilibrium. The buyers pay the higher price, the sellers pay the lower price, and we figured out that Q equals 15. We can do this graphically by taking a vertical line segment of the length 2, which is our tax, and then moving this in from the left until it gets to the point where it gets wedged in there and perfectly links the supply and demand curve with that length of 2. That happens right here at a quantity of 15. That is why we call this the tax wedge, because that segment of length t, the size of the tax in this case 2, wedges itself in between the supply and demand curves. And that's where we get our buyer price, seller price, and quantity, just the same as we did on the chart. This is also essentially what we're doing in both of those algebraic methods we did, where we added 2 to the price on the buyer side or subtracted 2 from the price on the seller side, essentially doing the same thing. The last topic to talk about for taxes for the moment is tax incidence. Tax incidence tells us how much of the tax is actually paid by the buyers and how much is actually paid by the sellers. Tax incidence is completely independent of which side is actually charged the tax. Remember, that doesn't make any difference. What does matter is the shape of the supply and demand curves. We calculate the tax incidence, also known as the tax burden, by seeing what is the difference between the original equilibrium price without a tax and then the price that either the buyers pay or sellers receive. So to calculate the burden on the sellers in our example, the sellers used to receive 6, they now receive 5, so their burden is 1 for every unit sold. To calculate the burden on the buyers, we take the price that they now pay, which is 7, we subtract the 6 that they used to pay without the tax, and we get 1. The burden on the buyers and the sellers must add up to the total size of the tax, which is 2. On the graph, I'm going to mark out our old equilibrium here. The burden on the sellers is this distance right here, which is 1, and our burden on the buyers is going to be this distance right here. It just so happens that the two are equal in our example, but that definitely does not need to be the case. Generally speaking, the side of the market whose curve is less elastic pays more of the tax burden, and the side that is more elastic pays less of the burden. As an example, I've sketched a market with a relatively steep or inelastic supply curve and a relatively flat, that is, elastic demand curve. The market price is somewhere about here. Now, if I were to just arbitrarily draw in a tax wedge, what we can see here is that the tax incidence on the buyers is relatively small, the tax incidence on the sellers is quite large. If I had drawn it the opposite way, then that result would have been flipped. One example that affects everybody here in the United States is the Federal Insurance Contributions Act tax, FICA tax for short. This is also known as the payroll tax. Half of the payroll tax comes out of your paycheck, and the other half is paid by your employer. The intention of this tax was to split the burden equally on both sides, but as we've shown, that might not be the case. It just all depends on elasticity. It's definitely split in some way between the employers and the workers, but not necessarily evenly as intended. That's it for now on taxes. Once we learn about welfare economics later on, we will come back to this and talk a little bit more about the effects of taxes. If you have any questions, feel free to let me know. Thanks for watching.